Alright, thanks for watching, and today we'll take it to the max because we'll show that the maximum of two continuous functions is continuous. And let me just explain what I mean by the maximum. So suppose you have two functions, let's say f and g, that not necessarily one is bigger than the other. So this might be f and this might be g. Okay. Then the maximum is just at every point the bigger one of the two functions. So the maximum in this case looks like that. So maximum of f and g. Or maybe as a better picture like this. Okay. Looks like very cycloidy almost, I would say. And what I want to show, so fact, if f and g are continuous at x naught, then so is the maximum of f and g. Okay. And to prove it looks very complicated, but it's not too bad at all, because turns out there's a nice formula that relates the max with absolute values. So fact, I want to say mact, no, fact, the maximum of f and g is none other than just 1/2 of f plus g plus 1/2 of absolute value of f minus g. And in fact, let's show it very quickly, so proof. So case 1, suppose f of x is greater or equal to g of x, then f of x minus g of x equals, So here's a quick proof. Okay. If you want case 1, suppose f of x is greater or equal to g of x for some x, then the maximum of f and g is f here. Then the maximum of fg is just f, and moreover, f minus g, because f is greater or equal to g, becomes f minus g. So you see the difference is non-negative, therefore the absolute value is just the function itself, and so what do we get? So 1/2 f plus g plus 1/2 absolute value of f minus g. That's just 1/2 of f plus g and then plus f minus g. This cancels out and we get 1/2 of 2f and we get f. And remember we said the maximum f of g is f in this case. And for the other case, it's entirely similar. If, let's say, g is bigger than f, then we get 1/2 f plus g plus g minus f, and that simplifies to g, which is the maximum. So case 2. So if f of x is less or equal to g of x, then it's similar. All right, very good. And how does that now show that the maximum is continuous? So what do we know? We again know that maximum fg, it's 1/2 f plus g plus 1/2 absolute value of f minus g. But here's the thing. Since f and g are continuous, what we get is f plus g is continuous as the sum of two continuous functions. So 1/2 f plus g is continuous. On the other hand, we also get f minus g is continuous. Therefore, by a fact I've proven a couple of videos ago, the absolute value of a function is also continuous. Okay? And therefore, 1/2 of this is continuous. And therefore, the max is continuous as the sum of two continuous functions. So max fg, which is 1/2 f plus g plus 1/2 f minus g. This is continuous, this is continuous. So the whole shebang is continuous. Ta-da! And then just two quick remarks. Well, what about the maximum of three functions? fgh. Well, interestingly, you can just use the fact before because, well, the max of three functions is you first take the max of the first two functions and you compare it to the third function. And the point is, we've shown this is continuous. This is continuous. So the whole thing is continuous as the maximum of two continuous functions. So therefore, for a finite number of functions, the maximum is continuous. I believe for infinite numbers might not be true, because all hell breaks loose. And then, last but not least, what about for the minimum? Turns out it's also continuous. So, and this you can just do both ways. Either you show that it's 1/2 of f plus g minus f minus g. Again, with a proof by cases, or you can also show that the minimum of f and g, it's the same thing as minus the maximum of minus f and minus g. Kind of like we showed that the infimum of s is minus supremum of minus s. Kind of similar to that. And minus f is continuous, minus g is continuous, so the max is continuous, so minus the max is also continuous. So in the end, the minimum of two functions is continuous as well. All right, thank you very much.